between time A and time B. Then I would express it as AB with parentheses. This is telling me that it's happening between A and B, but not including A and B. It's happening between them. If it happens from A inclusive to B exclusive, in other words, we're excluding B. In other words, if excluding exclusive. So it's happening from A to B, including A but not B, then I would write that as A comma B, parentheses. So the square bracket tells me it includes that. The parenthesis says I'm not including that endpoint. If it happens from A to C, including A and C, well, it's including both of them, so I'm using square brackets, do AC. B happens between A and C, so I don't have to write B itself. This implies everything from time A to time C. And then if something happens at A and C, but not between, then I would just write A, comma, C. No brackets. Brackets, parentheses mean I'm including something in between them. Without the brackets, just write the letters down. Questions to hear? All right, so what I would like you to do, given the big four, I want you to tell me for the duration of this problem, when is the position positive, when is it 0, when is it negative? When is displacement positive, 0, negative? When is velocity positive, when is it 0, when is it negative? And acceleration, when is it positive, when is it 0, when is it negative? And I will give you some time to work on that on your own or with someone else. And I'm going to write up some alternate ways of expressing the same information, just so that you've seen that as well. All right, I need to erase, I'm going to erase this part right here. All right, anyone still need this upper bit?
given,
You basically have from A to D, so where's the position positive? That's what I'm asking. And then where's the position zero? Where's the position negative during the course of the problem? I believe with your displacement. You have velocity backwards. You're looking at position and classic mistake on acceleration.
for, you said velocity and acceleration?
No, velocity is backwards. That's positive, that's zero, that's negative.
Okay.
That's right. That's wrong, yeah, that's wrong. What about in between? You just, the way you presented it here, you're saying at those times, it's positive, but what about in between? You don't want me to look at this right now?
I have a question for the accelerator. Since it's speeding up, but then it's always going down. How would we represent that?
Leave it as speeding up and slowing down.
Because from lock, the velocity will be increasing, and then it'll start to decrease as it reaches the peak.
It's only increasing while it's still touching the hand. It probably starts after it stops touching the hand. So as soon as the lock begins, it's starting to slow down.
Oh, thank you.
Position is almost right, you got one small error. Displacement is good. And you assume it's at rest at time A.
Yeah, that's what I was.
Yeah, that's, time A is just after the ball is in. You're ignoring the in-betweens. Yeah, I only pointed out 4 specific moments in time, but the ball does exist between time A and time B, between time B and time C, and between time C and time D. Yeah, there's gonna be a parenthesis or a bracket somewhere. You ignore time D here. Yeah, but you have a parenthesis there.
Gotcha. Gotcha.
And so you've got there's one small issue here. You've ignored time A, this one, because you have a parenthesis there. And same classic mistakes he made for acceleration. Then you want to look at position again.
Okay.
Yeah, I'm expecting almost everyone to make the exact same mistake with acceleration that you two did. By the time the test rolls around, no, I'm not expecting that.
And that's sadly shocking, some people do it.
I'll let you, Dean, if you have a specific question.
Position, yep. Yep. One small issue with velocity. You ignore time A. Because you have a parenthesis there, you're not including A in this category, and A doesn't show up anywhere else. So A needs to show up somewhere. So I'm good with velocity now. The acceleration, you ignore time B. But even though it's different than the mistake that those two made, there's still an issue with acceleration.
You don't have it.
Alright, good with that. And then good with that. You ignore time A for velocity. That's parentheses there, so A is not included there. And you want A showing up anywhere else. So A should be somewhere in one of those vectors. And here, your issue B, yeah, they made a mistake. And also notice, so there's a problem with B here. You also notice that, you have A included twice, because you got the square bracket with A there, and you have A there. They will not be both at the same time.
Alright.
Despite the claim of many students do that. At least not in classical mechanics.
Is it reaching its maximum acceleration from B to C? Like C, is it-
The way that you've worded it has a.
Or it's, is it no longer accelerating after C?
Oh, it is accelerating. But there's an issue, your question had a fallacy already built into it. When you said, does it reach its maximum acceleration?
Oh, same acceleration mistake.
It's a parenthesis.
No, it's not a parenthesis issue. There's some issues there too, but, alright, so let's look at velocity. Alright, so the way you've written it out here, because you don't have any square brackets at all. A isn't, is that an 8 there?
Yes.
Okay, okay, so that would work. Yeah. Oh, yeah, your velocity is good the way you've written it. There's shorter ways of doing it, but it's good. Like that. Yeah, good with that. Okay, and there's shorter ways of writing that one. Acceleration. Acceleration's the biggest pain, with these type problems. Let's take a look as a group now. You've had a chance to think about it and struggle on. There are some, acceleration generally is the toughest one. And if you look at the older tests, when I asked for it, I asked for acceleration first and then velocity, then displacement, then position. And then I realized acceleration is the toughest one, so why don't I put that one last? So you'll notice that there's a switch in the order in which I asked for them at some point. If you look at all the tests, I don't have all the tests posted. But. So, number of people have got this one. Number of people forgot what position is. Position is where an object is relative to 0. Where's 0? Where is 0?
The ground.
Yes, right there, 0 equals ground. When is the object on the positive side of 0?
From A to D.
Yep, the entire time. It's never 0, never negative. So it's like you have a number line here, with zero here and positive numbers going that way, it's on the positive side all the time. Displacement, so it's overall displacement. That cares about starting point, so it's like you have a number line here with the positive numbers this way, negative numbers that way. Well, the problem starts at time A. Because the problem starts just after the ball leaves hand, and hey, that's the time, just after the ball leaves the hand. So it's at the starting point at the very beginning of the problem. At C, it's in the exact same spot. And then when is it positive? When are you on the plus side of the starting point?
From A
A to C.
Yep, not including them because they're over here. And then, if we've done it right so far, everything else should be negative. And that is indeed when it's below. So C, comma, D. Velocity cares about in which direction you're going. When is it going in the positive direction?
From A to B, including A, not including B.
What happens at B?
0 to 0.
And then if we've done it right, everything else should be negative.
Correct.
And again, I don't have to put C in here. Some people will put B, comma, C, comma, D with the parenthesis in the bracket. And that's not wrong, it's just unnecessary. And now acceleration. The most common mistake for acceleration is have acceleration as 0 at B. Think about that. Acceleration is the change in velocity over the change in time. If acceleration is 0, what does that say about the velocity? Not necessarily that it's stopped. In this case, it is stopped at point B, but if acceleration is 0, what does it say about the velocity?
It's not changing.
Not changing. Or is that, you said stop? Okay. It's not changing. So if I throw the ball up into the air and it stops right here, if the acceleration is 0, then the velocity doesn't change, which means that ball's gonna hover. Which would be a really cool effect if I throw a ball up and then it stops. However, if that's the way physics worked, then I think as a species we would have evolved much differently or died out. Imagine every time you jumped into the air and you never came back down. So acceleration is not 0 at the top. So let's think about that. As you're going up, am I speeding up or slowing down?
Slow it down.
So my velocity is positive, so my acceleration therefore is,
Negative.
yep. On the way down, speeding up or slowing down?
Space negative.
My velocity is negative, therefore my acceleration is,
Negative.
and so that works great except for this point right here, and it's also negative at that point. Why does the ball slow down?
Gravity.
I'll nitpick that later, okay. Why does it speed up on the way down? All right, more specifically, the weight of the object. Does the weight of the object change during the flight?
No.
The weight's the same, the force is always pulling it downwards. It just happens to stop at that moment, but the force is still pulling it down, that's why it then falls. Acceleration is negative the entire time. I also have some videos on this one specifically, so if you need to go back and relive the glory. I do want to point out before I get over to those, students sometimes get into a test and they go with displacement and position and suddenly they think, oh, what's the difference between the two? And so they just put down the same answer for both. I will tell you, for the problem like this, or the one that was especially the one kind of like what we're about to do, if you put down the same answer for position and displacement, I will give you credit for one of them, but not the other. Usually there's partial credit, but if you give me the identical answer for actually any of these, identical answer between any two rows, I will give you credit for one, but not the other. Because I will tell you right now, you will not have identical answers for any of these rows. I'm talking across the board. All right, other ways of displaying it. Some people find this one a little bit easier because you don't get the duplicates. I noticed some people left A off. or they left one of the letters off, but they did the parentheses bit, but they managed to leave something off. And that happens easily on this method. Over here, it's a lot harder, because you can see there should be, every square here should have either a plus, a 0, or a minus in it. So for position, it was positive the entire time. In this version of it, what I would do is I would just shade in the positives the entire time. Displacement was 0 at A and C. It was positive to start with and then negative. So over here, I would shade in 0, then positive, then 0, and then negative. I also want to point out, unless there's an issue with the problem, and there was one test where I did this. If you go from positive to negative or negative to positive, you better be passing through 0. There unfortunately was one test where I mislabeled, and so there was a jump, and so I gave a lot more flexibility and interpretation for that particular issue. Velocity was positive on the way up. It stops at B, and then it's falling. So this is positive, positive, 0, negative, negative, negative. And then acceleration was negative the entire time, so. There's a PowerPoint that's also you can find through Blackboard, Chapter 2, where I also write, it's a different problem, but I also do it where I just write it out in words, which I find incredibly inconvenient from a student point of view. If I were a student, I would not want to do that. I'd much rather have a shorthand notation. But, I do something similar with all the groups, and some people are just more, they enjoy writing more than I do. All right, questions about the ball problem? I'm gonna do one other thing with it, and then we'll do the test level problem. All right, the advantage of these two methods is you're less likely to leave something blank, although some students will, especially this one. If you don't have something in the square there, you'll left it blank. And it should exist somewhere. It should not be, it will only be positive, negative, or 0. It won't be any two of them at the same time. And I've had students on this method right here will duplicate it. So it'll be positive here and 0 at the same time. And occasionally I get positive, 0, and negative all at the same time. It will not happen in this course. Not legitimately. The advantage of this one is the next part when we're doing the graph. So if I did position versus time graph, velocity versus time graph, and acceleration versus time graph, this is something I've started in the last couple of years, is I want you to sketch a graph of what's going on. Now, in this particular case, we have 4 moments in time. We have A, B, C, and D. The 3 main things that I am looking for when I'm doing this, and there's some other smaller, subtler things, but the 3 main things I'm looking for when I ask you to sketch the graph. There are no numbers involved here, so there's some flexibility, but there's also some restrictions. So number 1, does the graph match what you have over here? If you're saying that the acceleration is negative the entire time, then your acceleration graph better be negative the entire time. 2, The graph should be differential at all points, except potentially the beginning and the end. What I mean by that is a smooth curve. You won't have any sharp points. No sharp points. And number 3, is the velocity the slope of your position graph? Is acceleration the slope of your velocity graph? So those are the 3 main things I'm looking for. I guess another thing is, did you actually go from the beginning to end of the problem? Because some people will just stop short for some reason. I always suspect it's a lack of confidence. You get so far and you think, I have no idea if I'm doing this right, and then they just, instead of putting something down, just stop. All right, so looking at this, notice I skipped displacement. The only difference between the position graph and the displacement graph is where it begins. Displacement graph will begin at 0. Position graph will start somewhere not necessarily 0. It's just a matter of shifting them up or down. So a position graph starts out at some point. It's a sketch. It's something positive because it's above the ground. It goes up at B, it's at the highest point. That B better be the highest point. And at D, it's just before it hits the ground. Now I happen to know this is a parabola. And that is a really bad parabola. At A and C, we should be at the same point. So notice here that I did my time units here in even increments, but in reality, it's not an even increment. The time from C to D is less than the time from B to C. So again, part of that sketch thing. Realistically, probably B, C, and D. Something like that. I'm gonna put B and C back where they were. Just because the others marked off that way. Velocity starts out positive. It's 0 at B, so at B I know it's at 0. It starts out, it slows down. As it slows down, and then it just gets faster going in the negative direction. I happen to know it's a straight line in this particular problem. And then acceleration is negative the entire time. Now, there's lots of different things I could write down there which are on the negative side of it. Well, let's think about slope here. So this should be the slope of this. So my slope is positive to 0. My slope is positive to 0. My slope starts out steep and gets less steep, so my velocity gets less. Here it starts out at 0 and becomes more and more negative. So it starts out at 0 and becomes more and more negative. That matches. Down here, what can you tell me about the slope if this is a straight line? What do you know about the slope of a straight line?
It's constant.
Yes. So we said acceleration was negative, and based upon this drawing, it should be constant. So constant negative. So that would be a sketch of this particular graph. Questions? All right, let's take a small little break while I set up the next problem. And we'll come back, we'll do one as a group. Yeah.
Can I talk to you on that real quick about?
Yeah.
this one?
Are you talking on the lab?
Yes, I asked him about the density. No, I asked him about volume, and what he said to do is we have to take the inside and subtract it from the outside.
Perfect.
The inside of what?
Like, So we had to find the volume for the outside diameter, and then we had to find the volume for the inside diameter, and then we subtract the outside diameter from the inside for it.
So we calculated the,
We calculated the inside diameter, and what we need to do is we need to subtract the